All right, welcome everybody to week 6, day 3. So I've just allocated everybody into a group. We've got Dad Bod, we've got Pizza Party, we've got group didn't show up on Friday, which is today, that has 26 students in it. Shame, shame, shame. We got Stallman's Rejects, we got the Immortals, One Piece, The Rods, Unstoppable, Pizza Party, and Chipotle 2.0. Please don't sue us for trademark infringement. So we are going to be working on your first group project, and it's very exciting stuff. So we will get to that in a little bit. There is one little bit of learning that I want to do first before we get into that. The two is an integer like a SQL title. Well, yeah, but like in computer science, we use 2.0 to indicate like a version, right? Like it's the second iteration of Chipotle. I don't know. I'll fix it for you. So let's talk a little coding here. Why is my keyboard not turning on? This is ongoing problem with IQ for some reason. If I switch my wallpaper, then my keyboard will turn on. It's so weird. Okay, there we go. That's nice. Now we got mouse parallax. Got to turn that off. There we go. Okay. So let's continue. Move main.cc to old main. I don't have the main.cc. Perfect. All right, then main.cc. All right, so let's talk a little bit today about 3 different options you have. So let's say you want to make 100 integers all at once. What options do you have? Option 1 is the integer array C style array way of doing it, and it looks like this: integer r equals 100. And there you go. So this is how we did things in 1980. Okay, then there's option 2, which is an integer array, but it's a C++ style array. And this requires us to hashtag include array. Array int 100 r2, and then we have option 3, which is called a vector of integers, and this is also C++. Yeah. It's not in C. So if you're writing a lot of code in C, this is kind of your only option. If you are using C++, which this class is, you can either do things this way or you can do things this way. And let's compare and contrast the options. So arrays, bullet point 1, don't initialize the elements in the array. Okay. So if you were to do something like print out for int x and r cout x, so if you're going to print out all the elements in the array here, and we can do the same for r2 if we wanted. So cout r. Speaking of which, Sea Shanty Night is coming up. Sea Shanty Night will be 2 Tuesdays from now at 5 o'clock and AC1 150. So be sure you are there if you would like to get some extra credit from learning about sea shanties. And extra credit will be provided if you cosplay as Luffy or something. Okay. So here we have r. So r is a C-style array. You can see all these elements are 0. See, professor, what are you talking about? Everything is initialized as 0. Oh, except for those couple ones there. See, they're all 0 except for those couple ones there. They're all 0. What are you worried about? It's mostly 0. You can trust that there's 0, right? No. And then for R2, you can see that they are filled with all sorts of... there's a couple zeros in there, but mostly they're not 0. I would like to say it's completely random if those elements are 0 or not, but it's not random. You could, if you were to really dig into things and look at the assembly, you could probably find out why those values are set. But it's not worth the time. The upshot is that it's dangerous to do this. If you're using elements in an array that are non-initialized, you might get 0, you might get something else. This is danger. Okay? So this is danger coding, right? Vectors always initialize all their elements. So if we're going to do this for vector, for vec over here, what's your vector? If we're going to do vec over here, print out all of our elements in the vector, you'll see we get all zeros, right? All zeros. Vectors always initialize all their elements. Now, some people think this is a positive for arrays, and maybe it's true. Maybe it's, you know, danger coding, it's faster but unsafe. And vectors are slower and safe. But a lot of the time, you're going to want to initialize all the elements in the vector anyway for safety, so there's no real speed benefit to it, because if you're the only time it's actually a speed benefit is like if you're making an array and then you're like reading into that array from like a file or from the network or something like that, then yeah, okay, maybe there's a very, very small speed boost from that. So I'm not going to tell you never to use arrays, but I will tell you never to use C-style arrays. This is a never use this option. Okay? And this is going to like make a lot of people salty. But there's actually no good reason to use a C-style array ever. You need to be able to recognize it so that when you see it online, because your Zybooks and your Zybooks are going to use it, you're going to see code online if you go onto Geeks for Geeks. They use C-style arrays. I don't know why. It's not a good option ever. If you're using modern C++ and you want to use an array and you want to get the faster but unsafe benefit, use a C++ style array. Okay. The reason why this is bad is because C-style arrays don't carry any size information. In other words, you don't actually know how big they are, like especially if you pass them to a function. So if you were to pass something to a function, void print the array, and you pass in a integer array, you don't know how big this thing is. And this thing actually does something called pointer decay. So this thing is actually just something called a pointer, and this is just a memory address where the array starts. Okay? You don't know where the array ends, and that is super, super double plus ungood bad. Okay? It is really bad to have a starting part of a range and not know where the end is. This is ultra dangerous code. And like the way that they handled the end of an array back in the day was like for a string, a C-style string, they just put a 0. And so you don't know how big the string is. You just keep going through it until you hit a 0 character, the null character. You're like, oh, I guess that's the end of the string. But if you don't ever find that null character, then you just keep going and you go through memory. And it has caused more hacks and more bugs and more seg faults and more crashes than anything in the world. And the reason why it's so stupid and so bad is because in the 1970s, it was about $1 per byte of RAM to hold something. And so holding the size, sometimes you didn't need it because, like, you know, you can get away with just putting 0 in the last element. There you go. That's the end of the array. You know, if you use 4 bytes to hold, you know, how many elements you have in the array, that's $4. You know, your program just costs $4 more. And so that nowadays we've got like just, you know, do you want 32 gigs or 64 gigs? Nobody cares about 4 bytes of RAM anymore. A vector, I think, is probably going to be around maybe 8 bytes of overhead, maybe 16 bytes. I'm not saying 8 gigabytes. I'm not saying 8 kilobytes. I'm not saying 8 megabytes. 8 bytes of overhead, maybe 16, something like that. Yeah, it'll be 16. There's 2 pointers extra over. Yeah, it's like 16 bytes of RAM extra. So that is just not a concern on any modern system. If you're doing embedded programming, maybe, but you could still use this because it doesn't have that overhead. Okay. So plus, it is 16 bytes of RAM cheaper. Negative, your code is dangerous. Okay. Vectors always carry their size with them. So you have no idea in this function here how big this array is. You know where the beginning is, you don't know where the end is. Good luck. Hope you don't crash anything. Hope you don't overwrite your social security or your bank account information or anything important. I just hope that just works out for you. Now, a lot of people are going to do something like this and say integer, you know, size like that. And then they will say like 4 and equals 0, I is less than size, I plus plus. cout ri. And so now instead of printing the array this way, we can print the array this way. Too few arguments. Oh yeah, we need the size in here. And the size of it is 100, and you better hope that the 100 here is the same as the 100 here. If you screw that one up, if you like make this one bigger, you're gonna go out of bounds. If you make it smaller, you're gonna go out of bounds. You know, or you're gonna go out of bounds, or you're not gonna print the whole array. Either way, it's bad. You have to make sure that this number here and this number here are the same always, no matter how many lines of code you put in between or how many times you change it. You always got to make sure they're synchronized, whereas a vector just always carries that data with them. So if we scroll up, you can see here R, it's mostly zeros, and it's got some elements in it. So that's how you print a function. But guess what? Guess what? If you're passing the size, well, there's your 4 bytes that you were gonna, need anyway. So there's really no benefit to it. Okay. Basically, anytime you're gonna have an array, you're gonna also track its size. And so there's really very little benefit to and again, like we've got like 32 gigs or 64 gigs on a modern PC. 4 bytes of RAM is utterly insignificant. If you're making 100 integers, that's 400 bytes of RAM. 4 bytes of overhead is like a 1% increase in RAM. Nobody cares. Okay, literally nobody cares these days, except for people that are coding on very, very small, cheap embedded systems. They might care, but even still, they're probably going to want to use this instead. Okay. This Thursday, no, it's 2 Tuesdays from now. It's going to be on the 27th, September 27th. So, all right, what else? So arrays are what are called stack allocated. Okay. Stack allocation is faster, but is limited to 100 megs of stack space total. It's also faster because it doesn't initialize it. Okay. And vectors are what are called heap initialized, and I'm going to draw you out a picture in a second. Heap allocated. Heap allocation can go much bigger. On our system, it's limited to 2 gigabytes, but has a slight cost overhead to allocating. So every time you make a vector, there's a very small amount of time that it takes to, it kind of hunts around in RAM to find a chunk of memory big enough to fit it. It's like, okay, here's your chunk of memory, it's yours. And that searching around takes a little bit of time. It's not a lot of time, but it's not 0 time. Like stack allocation takes as much time as it takes to do a single addition. So it's very, very fast. Heap allocation, it's actually kind of hunting around in a data structure looking for like an open chunk of memory. And that can take a little bit of time. It's not very much time. It's not enough really to worry about. And so if you are going to be making, so if you're going to be making like 100 integers like millions of times a second, and you need exactly 100 integers, and you're making it 1,000,000 times a second, then yeah, I would say use this. Okay, that's like why the C++ style arrays exist. They exist because it's a very fast thing to allocate. It's very fast to deallocate. A vector is slower. If you only do it once at the start of your program or once every so often, nobody cares. It's not a big deal. Whatever. It's not actually that slow to allocate. But if you're doing it like millions of times a second, yeah, you probably don't want to be allocating and deallocating a vector 1,000,000 times a second. That's probably going to degrade your performance. Okay. So some of the time you're going to use an integer array. Most of the time you're going to use a vector. None of the time you're going to use this. Okay. You should use this never. None of the time. In this class, I don't want to see you using a array, a C style array ever in this class. There's no reason for you to use it. This is my maybe like 5% of the time, and this is the other 95% of the time. Okay. And so we had one of my former students who's working at Microsoft now. He came in. He said like basically everything they use at Microsoft is a std vector. They use hash tables, which is something you'll learn about in 41. Maybe we'll learn about in this class. Basically, between hash tables and vectors, that's basically everything you use, and then you might custom code solutions some of the time, stuff like that. Okay. So why is this bad? Well, it doesn't track its size, it doesn't initialize its elements, and then it can't grow. And so one of the huge benefits of this is that arrays can't change in size. They're fixed size. They're always going to be 100 elements. Whereas a vector is dynamic, okay? Can grow bigger or smaller over time. So if you think you need 100 elements, but then you find out you need more, you can just make it bigger. It's not a big deal. Arrays can't do that. Arrays are fixed. They can't change. So, yeah. So let's show you what happens if you make an array too big. Let's make this array here 100 megabytes in size. Sorry, not commas. If you want to use commas, you use apostrophes. And so if you put an apostrophe into an integer like that, it doesn't do anything. It's just like having a comma, right? When you write out numbers for real, it just kind of helps keep you track, you know, ones digit, tens digit, hundreds, you know, so on and so forth. Okay. So yeah, it's just very nice. Yeah, it is. It really is. And you can just use that because otherwise you're sitting there like thousands, million, 10 million, 100 million, you know? And so they added that about 10 years ago, I think. And so now you can put apostrophes in the numbers, so you just kind of count out the digits a little bit more easily. So if I make a C style array and compile it and run it, we get a seg fault. Why? We ran out of stack space. Okay. So a lot of times you're going to need an array bigger than 100 megabytes, right? Like if you're doing any photo editing or anything like that, audio editing, like a lot of times you just need to have a large, you know, chunk of data that's going to hold all of your colors and whatnot. You cannot do it using a stack allocated array. Because remember, your entire program has about 100 megs of stack space. And so if you ever try to do anything like this, where you're like holding your, like, you know, you're doing movie editing, like you can't fit a movie in, like, no. Like, don't hold it in stack. You have to hold it in heap. Heap is, you can make this 100 million. No problem. Okay, let's make this guy smaller again so we don't crash. And you can see that, there we go. So that was it, I think, zeroing out 100 million values, right? So you saw that noticeable pause, all right, when it was initializing all that memory. So like I said, you know, slow and safe versus fast and unsafe. But if you need a big amount of data, you know, you gotta allocate off the heap. Okay. So yeah, but it didn't crash, right? Okay. So that is like my little thing there. Basically for this class, you should never need to use an array. Okay? Like, you don't need fast and unsafe for anything in this class. Nothing in this class is going to grade you based on shaving a microsecond off of your running time at all, you know? And so it's much better for you to be safe and to make sure your values are all initialized and it doesn't seg fault and things like that. So for this class, you basically aren't going to need to use arrays. You're going to need to recognize them so that, like, because you're going to see a lot of people out there, like if I were to just randomly pull up like Geeks for Geeks or something like that, like, I don't know, array examples or something. Array. Top 50 array coding problems, peak element. So they give you an array, you know, like that's the thing. They will give you arrays and they love arrays and there's absolutely no reason why they should. Like, honestly, there's just no good reason to use it. People just use it because their professors used it. And why did their professors use it? Because their professors used it. And why did those professors use it? Because their professors used it. Going all the way back to the Stone Age. And there's just a better option now. And just a lot of people don't know about it because their professors don't know about it. And it's called a vector. So just use a vector. And there you go. Anybody, I'm not going to say you're wrong for using this some of the time. But if you do ever use the C-style array in this class, it's wrong. It's the wrong choice. You've just made the wrong choice. I know there's always pros and cons to everything, but you're just wrong if you use the C-style array in 2022. Okay? You just are. If you really need you know, that speed and unsafety, use a C++ style array. It's just better. It has the size, right? So if you were to pass, you know, if you've got a, you know, print function void print r2 array print 100 r2, you don't need to pass the size in. Why? Because it's got a size. Just like that. Okay. And so this is dangerous, right? Because you're passing in an array and passing in a number that hopefully is the same size as the array. With R2 here, you can't ever have the wrong size. That is always the correct size. Okay. So you can't have a situation where the array changed sizes and this one didn't, or this one changed sizes and this one didn't, right? This one, you always know what the size is. It's just better, 100% better. Okay. So don't listen to, you know, dinosaurs. Now, that said, in some industries, yeah, they code in arrays, and that's, you know, like the automotive industry, like they code in arrays, right? It's just you know, standard practice there. And so, should you learn arrays? Yeah, you know, if you're going to be working in an industry that is still coding like it, you know, they're coding C, which is a thing, and or oftentimes they have a lot of interoperability between C and C++. Yeah. You're going to need to learn how to code in with C-style arrays. You're going to need to learn how to, you know, pass in a size and make sure you don't go out of bounds and all that kind of stuff. Like that's, you know, it. You know, I'm not saying that people don't code this way. I'm telling you, they do code this way. People do code using C-style arrays all the time. It is very common. Whenever I see a solution on like Geeks for Geeks, they almost always solve it with arrays instead of vectors. You know, that's why I'm telling you, it's a common thing. In this class, though, you should never be making that choice to make a C-style array. Okay, it's just not it's just not necessary. Okay, so yeah, boomers, right? Okay, so that is that. Let me draw you out a picture of how memory works. There's something called the memory model in C++ that kind of is an idea, high level idea of like how all this stuff works. Let's see here. Let's go to OneNote. And let's go to C-Site 40. We're going to go to memory, the compile stage memory model. Okay. So you can think of RAM as like a giant thing. Starts at memory address 0 and goes up to memory address 7, whatever. What the heck? Why did you write 0 times 0? Why did you write 0 times 7? What does that mean? Well, whenever you deal with memory addresses, like if I were to like print out, if I were to like print out this guy here, you see how this thing looks like a weird like star thing? That means that's a memory address. So it's just passing the beginning of the array. It doesn't pass the end, right? That's wrong. So if you were to actually like print that out, like print out R, and then we'll just like quit the program so you can just see that and not see all the zeros coming out. You get something that looks like this. This is the memory address of R. Okay. And you can see the top of memory is 7 So this is a little bit below the top of memory. So what the heck does this mean? This is something called hexadecimal. So hexadecimal numbers are indicated by the beginning of 0x. That does not mean 0 times something there. No. The 0x just means it is a hexadecimal number and doesn't convey any other information. So what is hexadecimal? Hexadecimal is counting from 0 to 15 per digit. Decimal, our normal base 10 system, counts from 0 to 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hexadecimal goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So F is the biggest digit in hexadecimal. And so you can see 7, so if the top bit is set, it's a negative number. So 1, 2, and 4, the 8th bit is actually -8. So the highest number possible is 1 plus 2 plus 4 is 7. And then after that, all ones. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, F, 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 F. Right? 1 plus 2 plus 4 plus 8 is 15. So 7, F, 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 F is the highest spot in memory. And so that is where the stack lies. So the stack is up here. This is called the stack. Okay, and it's at the top of memory. And the stack grows downwards. Every time, all of your variables, so if you have some variables in here, you got variable A and B and C, they all live in the stack. And if you call a function, like let's make a function called, I don't know, call it like friends or something like that. And friends has a integer named Ashley. It's equal to 42. And we have a string named Betancourt that is equal to what's up. And we've got a float named Aaron that is equal to -0, which is a thing. This memory here, if I were to call friends from main, if I were to just call friends, you might be like, well, this code doesn't seem to be doing anything. And it doesn't. But when you call it, what happens is that it allocates enough memory to hold these variables. So I could be doing things. I could say like Aaron like plus equals Ashley, right? Something like that. And I could be outing things. And I could out, Betancourt, followed by AA run. So the point is, like when I call this function, all these variables here need to be allocated. There needs to be room in memory for them to exist. And so when you start off, the only variables that exist are the variables in main. So all main's variables are here. And then when we call friends, there's something called the stack pointer. The stack pointer is normally pointing at the bottom of all these variables in main. And when we call friends, like that, the stack pointer moves downwards. How far does it move down? It moves down far enough to hold these values. 16, 20, maybe like 32 bytes, something like that. There's a return address that has to be stored, something like that. It'll move something along the lines of like 32 bytes downwards. And the stack pointer is now going to be pointed here. And now Ashley is going to exist right here. And Betancourt right here. And Aaron right here. And we can set the value of Aaron to -0. We can set the Ashley's value to 42. And things like that. So when the function returns, it does all the stuff. It does some math. All the variables, that's where they live in RAM. And when the function returns, the stack pointer just moves back up. And so what does it take to allocate all this memory? You just subtract stack pointer minus equals 32, because we figure there's about 32 bytes of RAM needed for this. I'm just estimating. I don't know exactly. But you just do that. And so that's all it takes to allocate all those variables all at once. Is just one subtraction. Okay? Then when the function finishes, the stack pointer just goes back up, and all those things go away. And so these variables used to be called auto variables. Automatic. Because they automatically allocate the RAM, and they automatically deallocate the RAM. We call them today just regular, boring, normal variables. Because we don't even think about where that RAM comes from, right? We just make integer x, and the variable exists, and we can read and write to x, and whatever. We don't even have to think about it, okay? But back in the day, they were called auto variables. And wouldn't you be a pointer to a character array? No, you're a string, because I said you're a string. So back in the day, you could actually write a variable like this. You could say auto integer Ashley, and that means stack allocate Ashley, okay? And as it turns out, this does nothing, because if you leave off auto, guess what? It stack allocates it. And so literally nobody used this keyword in C++ because it didn't do anything. So why type it, right? And so in C++ 11, they're like, hey, we've got this reserved keyword. Nobody can use this keyword. Nobody can make a variable named auto, by the way. If you tried making like a string, named auto and set it equal to car or something like that, it doesn't you can't do that. It's a reserved keyword. Okay, you can't make a variable named auto. So what they did was they repurposed the auto keyword so that you could do this now. And so the auto keyword, this is a learning point for today, by the way. You might want to write this down. Learning point number, 2 or something. The first one was arrays versus vectors. Learning point number 2 is auto means figure out my type from the right-hand side of the equals. Okay. So everybody, let's do some audience participation. What is Ashley's type? Int. Very good. Very good. You guys all got that one. Okay. All right. What they said. Okay. What about now? What type is Ashley? String? It's not a string. I don't see no double quotes in there. Float, floor, auto, size T. Looked at the wrong one. No. Ashley. Ashley, not Betancourt. Yes, Ashley's type is not float. This is actually a double. Okay. So this, if I wrote auto Ashley, that is the same thing as writing double Ashley. Okay. So there's two of them. So what if I were to put an F here? What type is Ashley now? And if I'm embarrassing you, Ashley, let me know. We'll get to Betancourt next. Okay, cool. Yes, it is a float now. Very good. So if you put an F here, that makes it a float. If you don't have an F, it's a double. Anytime you have a decimal. This is a double also. 42 dot is a double. Okay. Now she's back to being an integer again. So if we do a Betancourt, what type is Betancourt? I love being beaten to death. Who said that? Betancourt, making it self-referential. I am the type of Betancourt. String, 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 wool. String, string, string. String cheese. All of you are wrong. Betancourt is not a string. He's not an int either. So remember how I was telling you that C strings have this weird thing that they're actually not a string, but they're actually an array, and you don't know how long they are, and so there's like a null character at the end of them. That's this. So this thing here is actually a const char star. So it's actually an array of characters. And so if you want to actually make it a C++, because so like if we tried doing something like this, we tried saying like Betancourt, Betancourt.size, this doesn't work because Betancourt is not a string. Betancourt is an array of characters. This is C. This is like 1980s, C array. Okay. So you cannot get the size of it because he's not a string. He is an array of characters. Okay. If you want to make it a string, you do this. So, yeah, it is a const array, so you can't change it either. So if you want to make Betancourt a C++ string, you can slap an S at the end of it like that. And then that becomes an actual C++ string. And you can see you can get how many letters are in Betancourt now. It became the array I sought to destroy. That's funny. So, you guys all see that? It looks a little weird, but, you know. And then Aaron, yeah, we've already gone over int and float, so we're fine. Okay. All right. So that's a little bit on auto. Usually we use auto in two different circumstances. One is like when the type of something is like really, really long, like the type of like, I don't know, like a iterator is like kind of stupid. Vec.begin, CPP reference. So what is the type? They're not actually making a variable the type because they don't want to type it either. Yeah, they don't even want to type it out now. Yeah, the type names like iterators and things like that are like this long. So we typically use auto because we don't want to type all of that. And then the pray for Aaron, he's doing calculus. And then the other reason why we use auto is like if you want like let's say we have integer Ashley here, and we want Aaron to like follow her, right? So we want Aaron's type to be whatever Ashley's type is, right? And so like if we ever change Ashley from like an int to like a long, now Aaron's type is going to be long also. You guys see that? So if you've ever got like a bunch of variables that all need to be the same type, then then you only have to change it once, right? We change it from a long to a long. Now Aaron is a long instead of a long. Okay. So what if you don't want to change? Change is inevitable. So Ashley is now an integer, Aaron is now an integer because Ashley is an integer, and so on and so forth. So those are the two main reasons why we use auto. Okay, back to OneNote, which is different from One Piece, the group. So the stack is only about 100 megs in size, right? And so if you have a function call itself a bunch of times, you will eventually run out of stack space. So if we have, for example, the friends function, call friends again, this is an infinite loop, right? You call friends, it prints out some numbers or something, then it calls itself and it does it again, it calls itself and it does it again. And each time you do this, the stack pointer is going to move down 32 bytes, and it makes a new copy. You've got a second Ashley, you've got a second Bedencourt, you've got a second Aaron, and then when it calls itself again, you got a third Ashley, you got a third Bedencourt, a third Aaron, you call it again, and that's because each version of the function has its own variables, right? It's like if you change the variables in one function, it doesn't change the variables in another function. All those local variables, all of the variables you have here, are just for that invocation of the function. And so what happens is you eventually run out of stack space and you crash. Okay, so you get what's called a stack overflow issue, and that's what the website is named after. You get a stack overflow error. Overflow. And so if we just pull out the cout statement here, did this, segfault. Okay. So it very quickly ran itself out of stack space and killed your program. Okay. This is an infinite loop, right? Friends calls friends, and friends calls friends calls friends calls friends calls friends, and it just sits there and allocates more and more clones of Ashley and Bedencourt. It's like that scene in Toy Story. You know what I mean? Like there's all the copies of like Buzz Lightyear. It's like this one, right? So you got like one copy, and then you got more copies, and you got more copies, you got more copies, and more copies. And each one of those can have their own value, right? So it eventually runs the system out of stack memory, and it crashes. So so don't do that. So stack overflows are like actually a really nasty problem. You can't recover from them. If you run out of stack space, your program's dead, basically. It just kills your program. So yeah, so these are all automatic variables. Now, the contrast to automatic variables are what are called heap allocated variables. So where's the heap? The heap is down here, okay? So the heap is down here, and the heap kind of grows upwards. The stack grows downwards, the heap grows upwards, and if they ever cross like an imaginary line, then it kills your program. So when we allocated like 100 million integers off the heap probably grew upwards by about 100 megs, and like your vector is going to be like in here somewhere. And the heap is 2 gigs in size, right? So you have plenty of memory for most tasks on the system, on the heap. So you can do your photo editing and things like that. That all comes off the heap. It's a little bit slower, but in general, yeah, just use vectors for everything. Now, there's a couple other pieces of memory down here. There's what's called the 0 page, which I call the minefield of doom. Minefield of doom. That's my name for it. Apparently, the technical term is the 0 page, but whatever. And so if you ever try accessing the minefield of doom, it kills your program. The reason for that is because a lot of people have memory addresses that are initialized to 0, and they try accessing the memory there, and it kills your program because you should not be accessing memory at 0. And then above that, there is something called the code segment. The code segment is where your program lives. So your program is in RAM somewhere, right? Your hello worlds and all that stuff. You know, you've got like your couts and things like that. All that stuff lives there in the code segment. And if you ever get hacked, a lot of times what happens is that people will copy data from the stack. They pass so much data to the stack that it overflows all the way down to the code segment, and then they adjust the code. And that is called a buffer overflow bug, and has caused many hacks over the years. So the final, it's C array time and half the students seg fault. Yeah, use a vector. And then the final thing is for globals. So anytime you make a variable that is a global, it's not in any local memory. So like if I were to do something up here and say like integer score is equal to 0, this is held in the BSS. The BSS doesn't stand for anything meaningful. It's just the BSS. It used to mean something. It doesn't mean anything these days. It's just the BSS. Okay. Just how like a.out doesn't mean anything these days. It used to mean something. Nowadays, it's just the default name for an executable. It's Morbin time. Yeah. That's hilarious. So we've got here a variable, and all of these people can output it, right? So we can see out score from here. So this is accessing a global. You can print the global here. You can print the global, here. You can print the global here. All of the functions can access that global. Now, that said, it is generally considered bad design. This is considered bad design in most cases. Because if you have multiple functions all reading and writing to the same variable at the same time, it becomes very tricky to manage the state of the variable in such a way that doesn't involve like your code becoming incredible spaghetti. So reading from a global is fine. If you're writing to a global, you should really stop and rethink your life decisions. Sometimes it's okay. I'll sometimes allow it. Kind of depends. I always kind of get like I don't know. But if you had like a const or something, that's fine. Like const, touchdown is equal to 6 points. Const, like field goal, 3 points. Like, sorry, constant, I should say. Constant. Like that's fine. Like, everybody can read from it. Everybody's got the same number of points for all the things. Like that's fine. I don't understand any of these jokes. Morbin time. Marvel, the Marvel Cinematic Universe is kind of imploding right now. I don't know if you're aware of that. Like I watched every single Marvel Cinematic Universe movie up to Endgame, and then I've not watched a single one since. I don't think. I watched Spider-Man Far From Home. That's about it. So there was this movie called Morbius, I think, and Jared Leto playing Morbius, and there's not a line in Morbius where he says it's Morbin time, but it became kind of a meme back in spring. Like the movie was apparently so bad that people were just like, wouldn't it be cool if at some point he said it's Morbin time? And so people have just been using that as a joke. Everyone wanted him to say it, but yeah, the first movie to make $1 more billion. It's funny. So that's the reference. The Morbin lore, yeah. There's actually more to this. Oh, let me know. I did not watch Morbius, so you will have to enlighten me, Alessandra. Morblore, yes. He morbed all over the place. You sort of refused to watch it. Yeah, me too. I have no interest in any of the post Endgame movies. I was gonna see Love and Thunder because Thor's like my favorite superhero, but it's gotten very mixed reviews from people. So yeah, Love and Mid. That's funny. Morbius world. All right, that's pretty good. Yeah. So somebody created a petition to have them re-release the movie with him saying it's Morbin time. That is too funny. Anyhow, okay. So the BSS is globals. There is one interesting thing about globals that I should mention. A little bit of C++ trivia I should mention, and that is that globals are actually initialized to 0. Hey. Most people don't know that. BSS is 0 initialized. So everything in the BSS, all globals are initialized to 0. You don't have to initialize them to 0. It'll do it for you. So that's a little bit of C++ trivia. Maybe you can win a drink at CPPCon, which is going on right now in Denver, Colorado. So maybe that's where those people are right now. The people that aren't in this class, they're all over at CPPCon learning about CPP things. So, okay. Yeah, so that's a little bit of trivia there. And there we go. So segfault core dot. Let's see. We'll do that. There we go. Printing the memory address. Cool times. All right. So, any questions about this? The main thing I want you to take away from this, all this I've been lecturing for like 30 minutes, is don't use arrays, use vectors. There you go. All right. doesn't require much intelligence, or decision making. Just use a vector. You'll be fine. Okay. You need to know arrays because they are in common use. You're going to see people. You're going to see people using them. They're common in a lot of industries. Like there's a local company here called DPS Telecom. It became a meme on Reddit a couple weeks ago. And they use C-style arrays, so, and when they job interview you on C-style arrays. So it's like, okay, you should probably know them, but like when you're using them, if you have a choice, don't. Okay, simple. Okay, need it for another weekend. You warped on the carpet. You had to clean it up. You have so many questions. What questions do you have? Movie night on VC, Morbius. You have so many questions. Okay, mid movie. Did they re-release it with him saying it's Morbin time? They really? Yeah. Okay. You don't know what's happening. Okay, interesting. And R is bad. Okay, yeah, that's a good one. Yeah, that's a good one. I am going to save that one into my meme stash here. All right. Computer science. CSI 40 images, and there you go. We now have this in for posterity. Thank you, Min Crowley, for doing that. That is why Min Crowley is the best TA. Everyone, please give him a warm set of claps. Okay. So let's talk a little bit about the Mandarin assignment. I was up late last night helping some of you with Mandarin. Some of you might have saw me streaming Rick Astley's famous music video, Never Gonna Give You Up, in lieu of helping you. So so I'm gonna show you guys how I would solve the Mandarin assignment, okay? Because I know a lot of you are getting frustrated. I'm slowly like cranking the complexity of the homework assignments up so that you have to kind of keep stretching your brain a little bit. So I'm going to become somebody. Okay, so let's start from scratch. Okay, so we've got hashtag include iostream using namespace standard and main. And there we go. So you should have the magic memorized by now, hopefully. And the first thing I'm going to do is just, I don't know, like, see out hi. I don't know. Just take it one step at a time. You know what I mean? So we're just going to start off by printing hi to the screen. There we go. Like, legitimately. Like, when I start a new project, the first thing I do is I just make sure the compiler works. I can run things. For something like this, like on the server, like I don't usually test that, but like I've been working a lot on a Anaconda environment on my local machine, and so a lot of times I have to test, like, is this tool installed? Does the compile chain work? All this kind of stuff. And so yeah, usually when I move to a new environment, the first thing I do is just write hello world and just see if it works. Okay, cool. So now I'm going to run the input tester, and the reason why I'm running the input tester is because I want to steal these strings because I do not want to type them myself. Okay, you're more than welcome to plagiarize from the input tester to get the strings that you need. And YYPP D9W, D4W. Okay, so that sounds to me like D14W. There we go. One too many. Oh. And there we go. And I'm going to copy this. You can copy from any place except your friends, right? So the secret to success in this class is to not have any friends. Okay. So what step size do you want to use? Yeah, no, you can't copy and paste code. And that was something that Aaron was doing. He had up on the chat channel last night. He had like 30 lines of code, and I jumped into voice chat, and he immediately went bloop like that. He bloop, and you know that when somebody hides something, like immediately like, no, show me what you got. Show me what you got there, Aaron. He pulls it up. He's like, well, the code it's not functional. But it was still like 20 lines of code to solve the Mandarin assignment. So, beat Aaron to death. No, so I don't want you guys copying and pasting large chunks of code. What's a friend? It's real. Oh, that's funny. So the rule is like if you ever find yourself copying and pasting more than about 2 lines of code, you're verging into cheating territory. So don't do it. Okay. But you can certainly copy and paste from the input tester. So let's go ahead and do this and compile the code and run it. And there we go. And so input tester. And so good. All right. Our things are correct. Moving on. All right. So we need to make a couple variables or something like that. So we're going to need integer max is equal to 0, minimum is equal to 0, and step is equal to 0. So we are going to cn to max if max is less than 0, or they typed in a squirrel where we are expecting an integer, then die. And so I saw a lot of students copy and pasting bad input, quit over and over again. Don't do that. If you ever find yourself typing the same code over and over again, you should make it into a function. Okay, so we're going to make a void function here named die, and we're going to die hard to bad input like that, and an exit 1 like that. And now we don't have to type that code over and over again every time something bad happens, right? So we're going to enter max if max is less than 0, or they typed in a squirrel, we quit. All right, type in what number to start with. We're going to cn into min, and if min is less than 0, min is less than 0, or they typed in a squirrel, or min is greater than max, then we're going to die. We're going to do the same for step size, and we're going to say if step size is less than 1, or they typed in a squirrel, die. And now we are going to compile the code and we're going to test it. So anytime you write, you should be writing just a little bit of code at a time. Okay. And so we're going to count up to 10 from 1, step size of 1, good to go. -10, bad input, squirrel, bad input, min of 1, max of 10, but backwards, bad input, 1, 1, 0, bad input, 0, 0, 0, bad input. Okay. Test your code. Always test your code first. Like a lot of students will do this, then immediately jump into the input tester. No, you need to run your code yourself manually. Test it yourself. That's something that that's the downside to my input tester, is that students lean so heavily on the input tester, they stop like testing their own code and generating their own test cases and seeing if the code is working correctly. Okay, so. Wonder if auto can deduce it. Okay, so vim main.cc, and Mincarelli is making a joke that they won't get for a semester. So I don't know. Okay, all right. So next up, I guess I'm going to do a for loop. Okay. So for int I equals min, I is less than or equal to max, I plus equals step. This is like one of the learning points for Mandarin, which is to get a better understanding of for loops. Because the for loops we're doing, they follow a standard pattern, right? Like for int I equals 0, I is less than blah, I plus plus. This is the standard pattern, right? But pattern. But for this one, I explicitly made it so that like the best way of solving this is actually to have something a little bit different than the standard pattern. So this is the beginning number, this is the ending number, that's a less than or equal to, and the step size is not 1, but the step size is step. And so by doing this assignment and kind of getting nice buggy code, you get to kind of learn about for loops in a more like in-depth fashion. Okay. So we will just see out I. And then again, I've written 3 lines of code. Let's compile it. Let's test it. Notice I'm not trying to write the entire dang thing all at once, right? I'm not trying to write anything having to do with Mandarin right now. I am starting small. I'm starting just with step 1, okay? And turn off my phone. There we go. I'm starting small, and I write a little bit of code, and I test it. Okay, I'm not just using the input tester. I'm actually testing my code. I use the input tester to grab the strings, but... Okay, so let's try this out. Compile, run. I'm going to count up to 10, starting at 1 step size. We get the numbers 1 through 10. Okay, we're going to count up to 20, starting at 1, counting by 2s, 1 through 5, 7, 9. Okay, counting up to 20, starting at 2 by 2s, 2, 4, 6, 8, 10. Okay, looks good to me. In practice, I would test it a little bit more. But this is looking pretty good. Okay, so then the next thing we're going to do is just need to output the Mandarin version of I. Okay, so this code won't compile currently because there is no function called Mandarin, so we're going to have to make one. So we're going to make a function that will return a string and call it Mandarin. It takes an integer x, and we're just going to stub this out by just cout, not cout, not cout, not cout. Couting something is not the same thing as returning it. So when you return a value from a function, it literally takes the place of where the function call is. Right now, that code up there is not returning anything. And so that will actually segfault my code. It'll print ling to the screen, and you're like, oh, look, it worked. But printing something to the screen is not returning a value. Those are 2 completely separate things. You've got code. Your code is calling square root. It's expecting square root to return a value to it. If square root printed to the screen, 5.2, that isn't, I'm not getting a number back. Okay? So anytime you have a return type off a function like this, you have to return a string. This is printing a string. 2 completely separate things, and about half the students in the class, and myself included, I just did it, right? Make that mistake. So I'm going to return ling instead of couting ling. Okay, so we're going to try this out. See if the formatting looks right. I'm going to count from 5 to 10 by 3s, 5 ling, 8 ling, good to go. All right. Do you remember your bug from earlier? What was my bug from earlier? So I did do the cout one earlier. Oh, when I was overwriting right val? Yeah. Mm-hmm. Yeah, I remember. Okay. So what we're going to do is I am going to, first of all, just handle 0. So if x is 0, we are going to just return ling, and because ling is a weird special case in Mandarin, you basically never say 0 except when the number is just 0. Okay, so you just say ling and you're done. So that's a good case. But actually, yeah, I'll do this string right val and return right val. So my code is going to build up this string. So as we kind of process each of the digits of the number, we're going to like add to the string that we're returning. So you guys do know, right? You could say like ret val plus equals hello. Ret val plus equals world. And then what is this going to print down here? So this starts off with an empty string, right? No letters in it. This adds hello to it. This adds world to it. What is this line down here going to print? Yeah, for GDB. Yeah, we'll get to that. It will not print hello world. It'll print hello world. Hello world, no space. Right? Because there's no space in here. It doesn't add a space for you automatically. Okay. So yeah, so we're gonna build up this string. Hello world. It's caught me. All right. So what we're gonna do is we're gonna build this up, and we can approach this a couple different ways. The first way that I would handle it is by just handling the numbers from like 0 to 9, just one digit. Okay. And to do that, you did your code in a much more complicated way. Yeah, that's why I'm showing you how to solve this, because it's not like any of the individual components are that hard for students. But like when you've got a thing, calling a thing inside of a loop, calling a function, how you structure it, and more importantly, how you build it is the reason why I'm spending lecture time right now kind of showing you guys how to do this, right? So I would start off just handling one digit and seeing if I can get that to work. And if I can get that to work, then I'll try making it work with 2 digits. And if I can get that to work, I'll make it work with 3 digits, and so on and so forth. So I will say, if x is equal to 1, return e, yy, 8p. If x is equal to 2, return r, san, s, yo, chi, fa, jo. Okay. And yeah, let's try that. Okay, so let's count from 0 to 10. That's backwards, sorry. 10, 0 by ones, and so we got 0 is ling, 1 is e, r, san, and then we don't have any answer for any numbers bigger than that. Cool. So that all looks pretty good to me. All right. And if it doesn't work right, like if you have a copy paste error, for example, you might have left like 2 of these in there, something like that. Copy paste errors are very common. Test it. You test your code constantly. Test your code and make sure that it works before you move on. Okay, so we got it working for 1 digit now. So now we need to make it work for 2 digits. So how can we do this? So like, let's say int first, let's say the tens digit. Tens digit is equal to x divided by 10, and int ones digit is equal to x modulus 10. So this is the hard part of the assignment, is figuring this part out, okay? And then I can just convert the tens digit to one of these, and I can convert the ones digit to one of these, and I don't want to copy and paste this code. So what I'm going to do is I'm going to do like string int to Mandarin or something like that. I don't know. Digit, one digit to Mandarin. I don't know, something like that. Okay. And then I'm just going to shift V, select all this stuff, hit D, and hit lowercase p, and there we go. And if anything else shows up, we'll just return empty string. Okay. So always make sure that every path you take through your code has a return value on it. So you might be like, well, it'll never return a 0 or 10 or yeah. No matter what, if it's 42 is passed in for 1 digit, which should be impossible because this should only get called with a single digit. But let's say the horrible happens and you pass in something else, it'll just return an empty string. You always want to return something no matter what. If you promise that you're returning a string, you must return a string no matter which path you take through the code. Okay, so then let's just do this. So if tens digit, so if the tens digit is not equal to 0, which is the same thing as just saying if tens digit, then we will output cout, or actually ret val, right? So ret val plus equals 1 digit to Mandarin. Why did I make the function name so long? Okay, 1 digit to Mandarin, the tens digit. So like if we have 54, right? 54 divided by 10 is 5. And so the tens digit is 5. 54 modulus 10 is 4. So the tens digit is 5, the ones digit is 4. So we're going to convert the 5 to, right? And then we are going to, don't cout, ret val plus equals sure. And then we're going to add in the 1-digit to Mandarin for the ones digit. So we can just try this. Okay. Let's try this. Okay. See what this is. Okay. So we're going to count up to 20, starting at 1. Isher. Oh, no, that's wrong. Right? That's wrong. Ishiri, Ishir, Ishir-san, Ishir-san, Archer. Okay. All right. So this is wrong. So in Mandarin, there's a special case where if the first digit is 1, you don't say it. And you also don't say ling. In the previous class, I had a ling in there. And so so you have to like kind of special case those things. Right now, I'm kind of handling ling not popping out by just returning empty string. So that's that actually was avoided this class, but we still got to handle that. So okay, so we just special case it. If 10's digit is greater than 1, then we do that. And if we don't, we do. Let's add a space to the end of that there. And if 1's digit, let a space after the sure if the 1's digit is not 0, right? So most of the time there's going to be a space. It's going to be shiri, shir, shir-san. But if it's just like arshur, there's nothing after it, so you shouldn't print a space after the sure. So if the 1's digit is not 0, we'll put a space afterwards. Okay, and let's try that. Okay. So we're going to count up to 33 from 1. So your sense of sure, shiri, sure, sure. Okay, so that's all correct. Arshur, arshuri, sanshur, sanshuri. Okay, cool. We got it working. Now let's try it again up to like, I don't know, 110, starting at 90 by 1s. And so jioshur, jioshuri, jioshur, and then when we get up to 100, it breaks because we haven't handled hundreds yet. Okay, so do you guys see how that approach works? Like basically, I started it by working with just one number, and then I started working with 2 numbers, and I noticed that I was going to have to like convert. I was going to have to convert this, the 10's digit. I was going to have to convert that digit from a number into a string, and I noticed that this digit would have to be converted from a number to a string. And so rather than copying and pasting the code, I put it into a function. Anytime you find yourself repeating yourself like that, pull it out into a function, and then you can just use the function. Okay. Are you guys following like the approach that I'm taking here with this? Okay. It's actually really important to like incrementally work on things, because each one of these things isn't too hard. The hardest thing I think for most students was this part, like just how do I pull out the 10's digit and the 1's digit separately. But you need to just work on just a little bit of time. Don't try and do all of it at once. You'll confuse yourself. Okay, so now we need to do the 100's digit. Okay, so I do the 100's digit. 100's digit is just x divided by 100. X divided by equals 10 will work. Okay, so 500 divided by 100 is 5. 534 divided by 100 is 5. And then I'm going to divide it by 10, and then that... No. There. There. That's how you do it. So if we have 534 and we modulus it by 100, we get 34. And so dividing by 100 gives us the 100's digit. Modulusing by 100 gives us the remaining 2 digits. And then we can pull out the 10's digit and the 1's digit this way. And then just to avoid repeating myself, the 1000's digit is going to be divided by 1000 and modulus the 1000. And then the 10,000's digit is going to be the same. And normally I would be like testing this each step the way that we're running out of time, and we need to get to the RPG assignment. Okay, so So if we have like 50,000, if we divide 50,000 by 10,000, we get 5. And then we modulus it by 10,000. And so if it was like 5, 1, 2, 3, 4, if we modulus it by 10,000, it gets rid of the 5. You have 1, 2, 3, 4 remaining. Then for the next one, 1, 2, 3, 4 divided by 1,000 is 1. Modulus by 1,000 gives you 2, 3, 4. 2, 3, 4 divided by 100 is 2. Sorry. Is 2. And you modulus it by 100, you get 34. 34 divided by 10 is 3. Ring finger, don't worry. And then you modulus it by 10, you get 4, and then that's your 1 digit. Okay? And so basically, we're just going to repeat this process. So we got the 10 digit and all this kind of stuff. All right, so if 100 digit then now for this one, you don't special case it. So if it's 100, it's still e by, right? It's not for tens. You don't say e sure. You just say sure. For 100 though, you do say e by are sure. You know, you actually do have to say the one there. So it's actually even easier. So we're just going to do this and this. So right val 100 digit plus right val equals by 8. And then same for the thousands. That's Shin. And one more for the 10,000s digit. Again, each one of these I would have tested in one at a time, right? But we're running out of time, so I'm just kind of fast forwarding the process. Each one of those I would test. Okay. And I'm going to count up to 110 from 90 by ones. E by, we got an extra space in there. So we test. Joe. E by son. Okay, looks good. Let's count up to 210 from 190. E by Joe. R by E. R by R. Okay, looks pretty good to me. Let's try up to 1010 from 990. So what do we got here? Joe by sure. Joe. 1000R. Okay, that looks pretty good. 2020 from 1990. And so Vancouver housing market. Yeah, so that looks pretty good. Now, in the previous class, we had a bug. And the bug was fairly interesting. Basically, one of the things here wasn't a plus equals, it was just an equals. And so, so it was wiping out, so it worked fine up until, like, let me try breaking it here or something. Let's try that. Okay, so let me just recreate the bug or something along the lines. So we'll count from like 20 to 10 by 1. So sure, all that works fine. You test the numbers from like, I don't know, 80 to 90. It all looks good. You test up to 110 from 90, and it all looks good. Okay, cool. So it clearly works. 2010 from 1990, and what happens is the thing starts wiping out the numbers, and the reason for that is because this thing here is setting the ret val to just the tens digit, right? And so if you have 100 digit and 1,000 digit and 10,000 digit, it wipes it out. And so the way we went about debugging it is we did GDB. Let's see, it's line 47, GDB, a.out, breakpoint on line 47, run 2020, starting at 1990, one step size, and then it breaks. And then you can do things, you like print, what value does ret val have right now? Yiqian Jiubai, right? And then you go like next, and then you print the value of retval. And retval is now geo. You're like, oh shoot, we erased it. Oh, that's an equals, not a plus equals. You know, and so unfortunately we don't have time for me to fully go through that debugging process. But basically, what you'd start with is like setting a breakpoint, because like we're like, some of the numbers are getting screwed up, but it works fine at low numbers. Why is it breaking at higher numbers? You know, and so you'd probably like just have it break on Mandarin or something like that, right? So you'd say GDB it.out, break on Mandarin, run, and we'll count up to 2020, 1990, because we were testing our code. It was breaking here. Step size of 1, and here we are. So we can start hitting next, and you know, we run through this whole process here, and then we could like print the value of like the 10,000s digit, and 0, yeah, because we're going up to 2020, so that's fine. We'll print the thousands digit, 1, so we're at 1990, so that's correct. And so you can like print each of the values and make sure that they're what they should be. That's something you need to check. And then you can kind of watch the code as it's running. You can like print retval as it goes along. Each in geo by each one of those lines is run. Next, and then print retval again. You see, oh, it got crushed. Oh, that's, and do you guys see, like, GDB is very useful because like you could see out all the things, and a lot of people were see outing a lot of things. But at a certain point, they're just getting confusing. Like one person's just printing egg all over the place, and it's like, what does that mean? I don't know. And so see out all the things works pretty quickly when it works. When it doesn't work, you can switch into GDB and step through your code, and you can see the point at which retval changed, right? And you can even do something like watch retval, and then every time it changes, like it'll stop the code. You know, just kind of cool. Okay, so then main.cc, and then we fixed it. We're like, aha, that should have been a plus equals. And then input tester, and passed it all right the first time. Cool. So that's how to do Mandarin. Okay. The previous class I was failing some of the test cases because, like, where exactly you die on bad input, you know, I couldn't remember off the top of my head, you know. And so, like, I had to look at the input files, and let me just break it, I guess, for you, Mandarin. So, like, maybe if I was checking all these down here or something, right? Run input tester. We're going to, if I recompile it, we're going to, like, fail a test case, right? It's like, okay. So what you do if you're failing a test case, you don't know why, you should vim the test case, right? There's a test case. Squirrel Girl is the most powerful superhero in the Marvel Universe, which is true, by the way. And so you test, so then test your code. Like, try it. Like, okay, we're going to count up to 420, and we're going to type in squirrel, and oh, look, it continued on. You know, whereas if you look at the code that it's supposed to say, if you vim that, vim right-click, you see it stops immediately. Like, oh, okay. And so you can look at the input, you can look at the output, and then you can run your code yourself on it and see what you're doing wrong. It's like, okay, so that needs to like be up here, and this one needs to be like down here, and okay, you know what I mean? So when I did this in the 12 o'clock class, like I didn't have the checks in exactly the right place, and so I was failing some of the test cases. So I just opened up the test case, and I looked at the input, I looked at the output, be like, oh, that needs to be there instead. Okay. So good Mandarin lesson you got going for us. Yeah, if you're going to move to Vancouver, you know, it's good to know Mandarin. A lot of actually Cantonese is also pretty good to know there. All right. Okay. So let us talk about the RPG. So your assignment is homework, CSI 40, RPG 40. So you are going to be given the first open-ended programming assignment in this class. Yay! Everything that we've done until now has been very precise. Okay, so it has been testing your ability to do things correctly. Like, can you add two numbers correctly? And that's important because if in computer science you can't add or divide or multiply numbers correctly, your code's going to be really, really wrong. You know. And so I had some students complain like, oh, I don't feel like I have enough creative freedom on these assignments? And the answer is yeah, exactly. In computer science, computer science is a very creative science. It is a creative endeavor. But you also have to be precise when it calls for it. If I tell you to print out 100 numbers and you print out 101, that's not creative, that's wrong, okay? For this assignment, though, this is going to show you how much creativity there is in computer science. Computer science is a field in which there's a lot of different ways of solving every problem, right? Like if you're working for Facebook and you want to know how many friends on average people on Facebook have, there's actually a lot of different ways you can go about solving that. Or if you want to know like how many steps away somebody is from Kevin Bacon on Facebook, there's different ways you can solve that. You can start at Kevin Bacon and go outwards from Kevin Bacon and enumerate and just write down everyone's bacon number, right, as you go out. Or you can do it just for individual people. Like if somebody clicks on a button, find out my bacon score, and then it'll try, going through the network, trying to find Kevin Bacon. There's a lot of different ways of solving problems. There's actually a lot of creativity, and there's a lot of pros and cons. There's a lot of time analysis where you like try and figure out which one's faster. It's actually a really creative endeavor. It really is. And this is making a game. And so games are a great place for you to express your creativity. And so this assignment does not have an auto grader. There's no auto grader for this assignment. Why? Because it's creative. Like there's no right way of making an RPG. Instead, what you have are these things called design criteria. And so for each one of the design criteria you do, you get a letter grade. Okay? So I don't want to see anybody on this assignment getting a 0. Because if you do even just one of the letter grades, you get an F. But it's a high F. It's a 50% F instead of a 0. And some of these are like really easy to do. Like, you have to have colors. So just print out something in color and just turn that in and you get an F. But it's a high F. So, like if anybody gets a 0 on this assignment, it means like you didn't even like watch this part of the lecture. You didn't even try. And you're in a group. So somebody in your group has to just print out hello world in colors and you all get an F, right? And it's a 20-point assignment. It's a 20-point assignment. So please get an F on it, but a high F, not a low F. If anybody gets a 0, like it's like you're not even like in this class. You know what I mean? Because it's so easy to get an F, a high F on this assignment. Okay. So for each one of the bullet points you do, you get a letter grade. If you do none of them, you get a 0. Don't get a 0. It is so easy not to get a 0 on this assignment. Literally, you just have to just have ghosted me entirely to get a 0 on this assignment. So I'll just maybe I'll just drop people that, don't turn in anything. 0 points is me sad, exactly. If you do one of the design criteria, you get an F, but you get a 50% F. Yay. If you get 2 points, you get a D, 60%. You do 3 points, you get a C. You do 4 points, you get a B. You do 5 points, you get an A. You do 6 points, you get an A+, 810%. You do 7 points, you get 120%. You do 8 points, you get 130%. And this is a double weighted project. So that is 26 points. There is so much extra credit available on this. That is 6 points of extra credit that is available. That makes up for you not doing, one of the early 5-point assignments plus some. Okay? So I want you to go hard. I want you to go intense on this. You've got this weekend, you've got next weekend to work on it. Okay? Each one of the design criteria are going to be graded by me by hand. Okay? And so if you just kind of phone it in, I might not give you all the points for the bullet point, right? So like if you have like 5 puzzles to win the game, if your puzzles are what is 1 + 1? What is 2 + 2? I'm going to be like, okay, yeah, technically you did it, but I'm not impressed. You get like a point instead of 10 points. Okay? So all of these things are actually subjective, right? So if you're going to have puzzles, make them at least kind of interesting, okay? And you know what I mean? Yeah, basically, yeah, impressive. Like you don't have to like have like a holographic simulator puzzle or, you know what I mean? But like put in like, especially if you have 5 people in a group, if you have 5 people in a group, I don't want to see any of these bullet points be low effort. You know what I mean? Because each person in the group could have 1 bullet point all to themselves for like 9 days. Okay. So the world map, if you just turn in like something with like nothing in it, like, okay, you got a world map. Cool. But you didn't impress me. So I'm going to give you 1 point instead of 10 on it. Okay. So you need to make a cool looking world map. There must be combat. So there must be a world map you can walk around in, like a top-down scrolling game. If you don't know what an RPG is, an RPG is short for a role-playing game. If you've ever seen, I don't know, like Zelda 1 or something like that. Like a top-down, like kind of like one of these things, right? Just make something like that. Just make Zelda. You don't have to make Zelda with graphics and stuff like that. It could be all text, okay? But that's kind of the idea of what we're talking about here. We've got like a top-down map that you can walk around in, okay? And Legend of Zelda. Yeah, cool. So you must have a world map you can walk around in, and you must have some sort of combat. You must have some way of winning. All right. You have to have colors, and I'm going to show you guys how to use colors in just a little bit. You have to have 5 puzzles to win the game, and the puzzles I'm leaving that pretty open-ended. Again, if you do something super low effort, I'm just going to be like, okay, I'll give you a point out of 10. You know what I mean? So each of these things, like, you have to, like, don't do the minimum. Like, you don't have to do the maximum either, because the maximum is like making, a holographic labyrinth that is 7-dimensional. No, like, you don't have to do the max, but you have to do enough that, like, and also the more people that are in your group, the more I expect out of you. So that's true also. All right, so 40 lines of dialogue or descriptions of the world. So, like I said before class today, even if you're not good at programming, there is something that everybody can do on this project. So let's say you're not a great programmer. You can learn from the good programmers. All of you guys can go into like Discord. One person who's owning the assignment can share the screen. Everybody can look over their shoulder, and you can all voice chat together and talk about what you're going to code and what you're going to write and things like that. Usually there's going to be somebody that ghosts their entire group and doesn't do anything. If that happens, message me and I'll give them a 0. Again, you don't have to be a good programmer, because there's things like number 5 here. Number 5 is creating world building. You have to have dialogue. You have to have a theme. You have to have like a story or something like that, So when you walk around, you've entered the spooky house, and the spooky house is full of spooky spiders and stuff like that. When you walk in, a ghost talks to you and you talk back to it and stuff like that. So if you're not good at programming, you can do this. Everybody can speak English in this class, right? So you can write 40 lines is actually more than you might think, right? It actually takes a fair amount of effort. And so, I want you to impress me with your story and your theme and your world building and things like that as well. Don't just be like, hi, 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 hi. No. 1 point. Okay? So there's also extra credit available. Each one of the extra credits you do is a letter grade also. So one is using non-blocking IO. That means, do you see how, like in Vim right now, I can hit up arrow and down arrow and up arrow and right arrow and left arrow, and it responds immediately? It responds immediately because it's using something called non-blocking IO. So I've put an example of that into your RPG 40 directory that has a little bunny that moves around on the screen. You can take a look at that and see how that works. I'll do a little overview of that and a little bit. Composing original music and cover art. So suppose somebody in your group is good at music. Have them compose an original piece, okay? You have to upload it onto YouTube. Why? Because in the past, I had a student say they composed something, and then when it went onto YouTube, YouTube was like, oh, this is copyright artist, blah, blah, blah. And I click on it, and I'm like, oh, yeah, you didn't compose that, So it basically is using YouTube's copyright system for me to see if it's actually original or not. As far as cover art goes, I've had students try submitting like crayon sketches before, and if you think, is this good enough to be worth extra credit? It has to be like not, like, again, I'm looking for like not minimal effort. Okay, like you can't just be like, I'm just gonna check this box, It's crayon sketch, cover art, I'm gonna bang the piano. No, sorry, it's extra credit. I don't have to accept anything. Right? You have to make all of them yourself. You can't have your friends make the music for you. You have to make the thing yourself. The art, you can use AI art. We've been doing a lot of that this semester. So you can do AI art if you want. And but it has to be an original composition and has to be original artwork. So again, the standard is mid-tier, right? I'm not looking for any low-tier stuff. It's got to be at least mid-tier to make the grade. This is extra credit. You gotta impress me at least a little bit. Okay. So yeah, it doesn't have to be, again, it doesn't have to be max tier, but it has to be at least mid tier of effort. And like anytime I got a crayon sketch, I was like, no, sorry, it's got to be a little bit better than that. Okay. And then finally, an inventory system, so the ability to like pick up objects on the ground and add them to your inventory or drop things, or you start off with a dagger and then you can upgrade to a sword and then upgrade to something else. Having a system where you can pick up and drop things is a letter grade as well. And so the maximum grade, if you do everything on here, is 130%, which, because this is a 20-point assignment, is 26 points. And so that is probably pretty close to all of the points we've done so far in this semester. So don't skip this one, okay? Don't skip leg day. Don't skip RPG day, all right? This is your time to go hard on it. Don't ghost your group, because I'm going to ask the groups who did what work on it. And yeah, so if you ghost the group, there's a good chance you will get a 0. So pick something you can do. If you don't want to do any coding whatsoever, just take the dialogue, okay? Make a Google Doc, dump some dialogue in it, let the rest of the group deal with it, go, peace, I'm out, I'm going to not help at all, but here's some dialogue. Then you've at least done something, okay? Or at least, made, the music and cover art or something like that. Everybody's got to do something on the project. Okay, so when you turn the project in, you have to fill out the name of every person who worked on it. If somebody in your group ghosts you, don't put their name on it. Simple as that. Bullet points are, I did bullet point 2, 3, and 5. We didn't do the inventory system. We didn't do, we only did the music and extra credit. And here's a URL where you can view this stuff. Okay, so you have to tell me which bullet points you did. It's not like I'm going to grade you based on what you said you did, but it makes my grading easier. So like if you say that you did inventory, I'm going to look through your code for an inventory system and grade it. If you said I didn't do it, then I'm not going to waste my time like poking around like, is this an inventory system? Is this an inventory system? Where's the world map? Like they might have hidden it under like a question mark or something, I'm not going to go dig around for things that you didn't do. It just makes my life easier, makes your life easier. So don't claim that you did something that you didn't do, because then I'm going to get angry, because I'm like looking for your world map and there isn't one, So you just have to say which bullet points you did. So let me show you the demo code. So we got a bunny demo here, and the bunny demo I wrote in the 12 o'clock class. And so if we run it, we've got welcome to the spooky door, becoming in progressively darker red. I can slow that down for you if you'd like. It's not that one, Vim bunny demo. So let me explain first of all how you can use the colors library. So there's kind of like multiple tiers of difficulty of using the colors library. The basic tier is you can just see out red. So if you've included my colors library, you can just see out red, and then hello world will appear in red. Okay? And then if you want to reset the colors back to default, you can see out reset. And then if you want the colors to turn into green, you see out green, and things like that. So what did I forget here? Oh yeah, it's over here. Okay. All right. Okay. See out a number to continue. We already got an X. Whatever. Okay, so you can see here, it prints out hello world in red. It resets the colors back to default. It then chooses green, bold black, bold green, and then it continues on. Okay, so this is how, like, if you just want to like do minimal effort and get like half credit for the colors, you can just do this, right? Just echo red, your text turns red. Echo green, your text turns green. Okay, fine, easy. Okay, just include colors.h, and there's, if you want to know what colors are available, my header file is actually pretty well documented. Note that the colors remain if you don't reset them. Okay. Next. Okay, there we go. So if you edit, if you open up colors.h, you can actually see it's pretty well documented. Like it shows you how you can use each of these things. The colors are black, red, green, yellow, blue, magenta, cayenne, white, bold black, bold red, bold green, blue. Okay, so these are your basic colors. This is how colors worked in like the 1980s, okay? You just echo one of these escape sequences to the screen and it turns colors until you reset it. Now, if you want to do something better than that, you can actually do 24-bit color now. And this is actually fairly recent. Like this is actually within the last few years, PuTTY updated to be able to support 24-bit color. And so this changes the background color on the anytime you print a character to the screen, there's a background color. Like here, the background color is black, right? Here, the background color is white. And then there's the font color. Here, it's white, background color is black. So you set the background color, you can set the foreground color, and you can pass in a 8-bit number. So you can pass in a 24-bit color. So numbers range from 0 to 255. So 255, 255, 255, red, green, blue is white. 000 is black. 25500 is red, bright, glowing red, okay? And you can set the foreground color or the background color individually, 24-bit color options for each. If you want the colors to go back to normal, you call the function called reset color. So let me show you what that looks like. So we'll set BG color to be, I don't know, 60, 40, 200. I have no idea what color that's going to come out. And I will set the foreground color to be, I don't know, 240, 60. And you can see, there we go. So that you see the background color is pretty blue because it's 60, 40, 200. It's very blue, a little bit of red, a little bit of green. And then the foreground color is mostly red, a little bit of green, a little bit of blue. And so you can choose any color you want really to do that. And you can go into Google and go to like Google's color picker. See if, yeah, okay. So DuckDuckGo has one as well. So you just kind of find a color you like, and okay, 196, 89, 47. Just punch those numbers in, and have any color you want. You can type it into like a for loop, and like I got here, like the for loop is setting the color to I. So as the for loop goes from 0 to 255, the redness gets brighter and brighter. Okay. You can clear the screen. You can move the cursor around. So if you move the cursor to like 0, 0, the top left corner, this is the row, this is the column. So it's row, then column. Hit that. And you can see do you see how the red like kind of glowed in? I'll run that again. All right, kind of cool, right? Background color wasn't changed. I probably should have changed the background color, but whatever. So one more time. Look at the red for loop. Okay. So in this for loop, we're making it slightly more red every frame. Use sleep as a function. That should be 10,000. Use sleep is not just what students do in my class. It is it puts the program to sleep for a number of microseconds. And so 100,000 microseconds is like a tenth of a second. 10,000 microseconds is a hundredth of a second. So basically, it'll take this for loop 2.55 seconds to run because it clears the screen. It changes the color to be a little bit more red each time. It moves the cursor to the top left corner, and it draws "Welcome to the Spooky Door." And if we want, we could set the background color also to like start off as like very blue, and as time goes on, it will become progressively less blue, right? The first time through the loop, I is 0, so it's 100% blue. Then as I gets bigger and bigger, the amount of blue gets less, and the amount of red gets more. And let's see what that looks like here. Kind of cool. It's kind of cool. So, yeah, you can pick any color you want. Public color test, so you can see there's all sorts of cool colors available. It's 256-bit color. I actually made an image viewer that runs inside of PuTTY, so you can actually view actual images inside of PuTTY. These are all actually just characters. So this is just a bunch of spaces printed out. So it just prints out a space, setting the background color of it to be a sample from the JPEG. And if you were to turn the font size down all the way to like, I don't know, let's pick 8 at first. Then you'll get more and more detail the smaller the font size, as it grabs more and more points out of the image. And if we set the font size all the way down to 1, then you will actually get pixel perfect image viewing inside of Putty, which is really not something that I think anybody expected would be a thing, least of all the Putty developers. I sent them an email a while back saying that, hey, when I view a 4K image inside of Putty, Putty works really slowly. And they didn't respond to me, probably because they thought I was crazy. Why would somebody want to do that? Well, I don't know. It's pretty cool being able to view images inside of a text-based environment. That's just me, though. And if you wanted, you could do this inside of your adventure game. So you can. I've made a working Doom client inside of Putty. Right? It's possible to run Doom. Yeah, I've made it. We did it live in class. It took about 2 hours to do. The perspective correction isn't good, but yeah, it's a real time, game. So we have here me. What was that? Can't read that second character. Mima Noku. Maybe Mima Noku. Something like that. Capital something. So yeah, there you go. So you can do image viewing and stuff like that. Anything you want for the assignment, any theme you want is cool. You're going to show off all of your stuff to your fellow classmates 2 Mondays from now. Let's do 2 Mondays from now. Okay. What else do we need to show you guys? Yeah, so you can move the cursor around. So if we do something like this, where the cursor is going to move. So what I'm doing is I'm moving the cursor based on I. So as I increases, it's going to go to the right, and then it's going to loop around once it crosses row 10 and column 30, it goes back to 0. So if I run that, then you can see the thing moves around the screen. It's animating a little bit too quickly. So let's slow it down a little bit. So you can see it's moving, and when it hits row 10, it wraps around to the top. When it hits column 30, it wraps around to the left. You can see the spooky door is getting more and more reddish over time, and the background is getting less and less bluish over time as well. And so you can do animations, you can do full 24-bit color. It's not HDR, unfortunately, it's not 10-bit color, but you can kind of do whatever you want. And then you can do non-blocking I/O, where I'm hitting left arrow, right arrow, up arrow, and down arrow, and the bunny is moving around on the screen. I have it clamped so that it doesn't move off the top of the edge, it doesn't move off the left column or the top edge, and if you hit Q, it quits. Okay. You can use Unreal Engine, you can use Unity for this project. It's up to you. You still have to meet all the same design criteria. And so all of the movement things were basically out of time, but basically if you want non-blocking I/O to take place, you have to set raw mode to be true. So by default, C++ is in what's called cooked mode. So that's why when you type in like hello, like when you do a CN into a string, you type like hello and hit delete, and then nothing happens until you hit return. With non-blocking I/O, it immediately tells you if the key is hit or if the key is not hit. If there's no key hit, it returns error. And so, cool. Most of the time, no key is going to be hit. It's not really an error, but if you, just basically you check. All right, no key was hit. All right, go to sleep for a tenth of a second. If the user hits Q, it breaks out of the loop. If they hit up arrow, it reduces the row. Y is the row. So it reduces the row by 1 if you hit up arrow. And the reason for that, the reason why it reduces the row is because that row there, the top row, is row 0. So in computer science, 0, 0 is the top left corner of the screen. This spot right here is row 0, column 0, right here where my cursor is. I can't select just like one part. Like where my mouse is right here. That's row 0, column 0. And then as you move columns to the right, it goes this way. And as you move rows down, it goes this way. So row 0 is here. Row 5 would be like down here or something like that. Okay. So how do you get the terminal to refresh? I clear the screen. So I'm repeatedly clearing and redrawing the screen. It's a standard animation technique where You make Bugs Bunny animate by clearing the screen and drawing Bugs Bunny in a new place. And then you clear the screen and draw Bugs Bunny in a new place. You clear the screen and draw Bugs Bunny in a new place, and it looks like he's animating. Okay, so this is standard like animation techniques here. So clear the screen, change the colors, move the place where it's going to draw "Welcome to the Spooky Door." Then it pauses for 1/10 of a second, so it doesn't take place too fast. This thing here tells you how many rows and columns you have. This thing here is called a structured binding. It's a C++17 feature that allows you to return 2 values out of a variable, out of a function call, I mean. It makes 2 variables based on the results of this function call here. So it's returning how many rows is the screen, how many columns is the screen, it'll print it. And then it sets the location of the bunny to the midpoint. So X is set to columns divided by 2, not rows, because rows is Y, right? Columns is left and right, so that's X. Rows is Y up and down. Okay. I set the color to be like some kind of green color. I set raw mode to true, and then quick read is how raw mode works. So basically, it immediately returns if you hit a key or not. So if you hit Q, it just immediately returns and quits. So you don't have to wait for the person to hit Q and return. Okay. Most of the time, it's going to be error, and if it's nothing's hit, it just pauses for 1/10 of a second, continues on. If they typed into Q, it breaks. If they type an up or down arrow, it updates the position of the bunny. Clamp is a function that constrains the value to a certain range. So Y is constrained to be between 0 and rows -2, so you can't walk off the bottom of the screen or the top of the screen. X is constrained between 0 and columns -2, so you can't walk off the left or right edge. And I pulled it up a little bit because if you print things on the bottom of the screen, Putty will scroll the screen. So I just keep you from going too close to the bottom, because if you go to the bottom and hit inline, everything scrolls up by 1 and it looks really bad. Okay. Clear the screen, move the cursor to that location, Y then X, because it's always rows first, then columns. So you'll see YX a lot instead of XY. So rows, then columns, and then it prints the bunny, and we're good. And so this is a simple bit of code that you can just use the arrow keys and the bunny will move around on the screen. Okay. Yeah, that's about it. There's more demo code in the non-blocking sample, non-blocking IO. It shows you like how to make a map, how to get things out of the map, set things on the map. It's got some non-blocking IO stuff as well. Yeah, basically a lot of demo code to get you started. And that's it. So plot with your teammates. What kind of theme you want to have? Come up with a cool story. Yeah. Oh yeah, one more thing. If you like when you CN into a string, like you can actually type in a name like Bill or something like that. If you're in non-blocking IO mode, like if you're in non-blocking IO, if you've done this, a lot of times you want to actually turn it off and then do a CN into a string. So like if you're trying to like do a puzzle and it's like, hey, tell me what is black and white and red all over, right? If you're in raw mode, it reads one character at a time, right? It gets one character at a time, and so it's really annoying. Like, okay, what is black and white and red all over? Okay, they type in like newspaper, and you like have to read a character and like add it to the vector or string, and then read another character. If they type delete, you have to delete the last thing. It's super annoying, and so you can turn raw mode off. So CN requires raw mode off. Quick read requires raw mode on. And you can switch back and forth as you like. And so it's pretty common for students to like walk around on the screen using the arrow keys, and then when they walk over like a shop or something like that, they turn off raw mode, they set raw mode to be false. And then they like see out like, hi, welcome to the shop. And then you can, what's your name? You type in Bill, and they use CN. So if you turn raw mode off, you can CN and see out as normal. If you have raw mode on, you get that instantaneous, like you can use arrow keys, you can hit function keys, things like that don't normally work. CN does not work normally with like arrow keys and things like that. So you can switch back and forth, okay, depending on what you need. MS Paint kind of art, not good enough usually if you're talking about like, wanting to get the extra credit. Something like this, yes. If they did this in MS Paint, more power to them. But like, yeah, it's extra credit. I'm not going to accept just like, you know, spray painted, like, yeah, like, okay, these are actually, I mean, that's actually pretty good. I'd accept that. I'd accept that. Or that. Pretty good. Okay, all this stuff is acceptable to me. So if that's all, yeah, that, no. Definitely not. Nope. Try again. I don't know what's going on there. My Little Pony. Cursed My Little Pony. That's kind of funny. I mean, no. No. Yes. Yes. Definitely is okay. Probably not. Rainbow Dash. All right. Yeah, sure. All right, that's pretty good. No. Ew. Okay, that's enough internet for today. So, does it have to appear in the game? No, no, no. You're making a text-based game probably, so you don't have to have the art appear in the game. You can, and I can show you how to put images into your game that appear in Putty. It's actually not that hard. I just showed you, right? That tool already exists. I can show you. It'll be fun. But yeah, technically you just have to do the art and do the music, and just put a hyperlink in, and I'll just take a look at it. Okay. All right. So that is it for today. Hope you guys are excited for this. It's a fun project. You can really show off your creativity. Maybe on Monday I can show you some examples of what students have done in the past. You can use Unity or Unreal if you like to, but think about like what your partners are capable of. Like if one person in the group knows how to do it, then everyone else is going to be sitting around twiddling their thumbs. So probably, unless everyone's down for the idea, I'd probably just stick to like a text-based thing. Work together, have one person like streaming, and everybody's joined in on voice chat, and you all work on it cooperatively. My brother-in-law does a lot of work with like group projects and like he teaches at conferences how to do something called mob programming, where like you have 13 people in a group, and they like put the screen up with the code on it, and one person's like typing, and everyone's just like calling out suggestions and things like that. Oh, that's a bug. Like Vin Crowley does that in class all the time. When I'm typing, like I forget to return something or something's like, oh, you forgot to return something. I'm like, oh, thanks. And that's how mob programming works. Like everybody's kind of looking at the code at the same time. And even if you're not a great programmer, you can still learn from the people. So just at least be there, okay? Don't ghost everybody. If you ghost everybody, there's a chance to get a 0, okay? So that is it for today. Hope you guys are all excited, fired up, have a great weekend. Work on it this weekend, work on it next weekend, go hard. And there's a lot of points in the offing for you. So that's it. Peace out. I'll see you guys next time.